Guys, welcome back. We're doing real math today. We're doing the distance formula and the midpoint formula. So a lot of numbers. Hope you got your calculator. Now in lesson 3, we found the length of a segment by using the segment addition postulate. So today we're still finding the lengths of segments, but what happens if they take that segment and they plop it on the x and y axis or the coordinate plane? That's what we're going to be doing on the front of this paper. So example 1, let's jump right in. It says find AB. That means how long is segment AB here? Now, I can't just count it like I did when it was on the number line, just because it's like a slanted segment. So you're not going to be accurate if you just kind of estimate and try to count. So we want to find the exact length here, and they want us to round it to the nearest tenth. So sometimes you have to write the answer 2 ways. When they say find the exact length, don't hate me, but we're going to have to go back to algebra and remember how to do factor trees. So we're going to have to remember simplest radical form. I will show you if you forget how to do a factor tree. Do not worry. Okay, so I want to find how long is this segment. That's my goal. I will actually tell you guys there's 2 ways to do this. So I want to show you both ways. Sometimes that can be confusing, but I want to open up options for people because sometimes people pick one way or the other. So one way is to actually use Pythagorean theorem. So let me show you what I mean by that. Pythagorean theorem, if you remember, is a squared plus b squared equals c squared. And you use it on right triangles. I don't see a triangle here. I don't know about you, so I'm going to make one. So I'm going to go to this top point B, and I'm going to drop a vertical piece straight down until I'm like level with A. And then I'm going to take that piece over and connect it to A. Now I have a right triangle. So here's how you use Pythagorean theorem. And this is going to get me my answer. How long is that AB segment? If you have a vertical piece or a horizontal piece on the coordinate plane, you can count those, just not slanted pieces. So this segment would be 1, 2, 3, 4, 5, 6, 7 long. This segment down here would be 1, 2, 3, 4, 5, 6, 7 long. This guy is the one I do not know. I'm going to call him C, just for the sake of the formula. If you remember Pythagorean theorem, if you don't, that's okay. It's not super complicated, but those are called the legs. The slanted piece across from the right angle, that's called the hypotenuse, and that is always C. That goes by itself. So the way I would set up Pythagorean theorem here, it'd be 7 squared plus 7 squared equals C squared. And then I would do exponents first, order of operations. Then I would add those and say 98 equals C squared. I'm just solving for C here, so my last step would be to square root. Algebra starts to haunt us here. So sorry. Here's where the factor tree stuff comes in. If I do the square root of 98, that is a decimal, and they want the exact answer. I can go ahead and do the rounded answer. Nearest tenth, that's 1 decimal place, so I would say 9.9. I would bump it up, and I'm going to cheat a little bit. Down here, that's 9.9. Okay, but what about the exact answer? So what I want to do is take this square root 98 and do a factor tree. And if you forget, in a factor tree, you're just writing factors of every number. So I could do like 49 times 2. That's 98. Every number that's prime, you circle it, and you're going to stop there. But I can keep breaking down 49. I could go 7 and 7. Those are going to stop, though. 7 can't break down any further. So I look at all my circled numbers, and for every pair, like I have 1 pair of 7s, for every pair you bring one of those numbers out to the front. This 2 doesn't have a pair, so it stays under. So the exact, and that would be the exact length, is 7 radical 2. That doesn't mean a whole lot, I know. We would never think in terms of those kind of numbers in real life, but 7 radical 2 is just that same decimal. So just a better, more simplified way of writing it. Whew, I feel like that was already a lot already. So that's a lot. Like I said, can't use a segment addition postulate. So this is one way to do it. You're going to do these exact problems. So this is like half the lesson right here. But some people don't want to do that. They don't want to do Pythagorean theorem. They want a simplified version of the formula. That's where the distance formula comes in. This is the same thing as what I just did. It's just in like a formula form. It's super crazy looking. Don't be intimidated. Make sure you copy it down right. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, this looks terrible, but honestly, guys, the distance formula is really just Pythagorean theorem, but hidden a little bit. Let me show you. We just talked about Pythagorean theorem is a squared plus b squared equals c squared. All they did was they square rooted the c. That's what you're trying to find every time. You're trying to find c every single time on these. So the length of the segment is going to equal the square root. That's where that comes from. And then it's a squared plus b squared. Instead of it being a right here and b right here, they found that length by subtracting the x values of the points. And they found b's length by subtracting the y value of the points. I know, this is going to be kind of weird. Let me show you one last thing before we kind of jump back into it. So like a is -3, -4. You might be wondering like, well, where does all this stuff come from? Like, where do I find those numbers? Because x2 is just a number. You're going to use the ordered pairs of the points for that. So like, the first number is the x, the second number is the y. There's going to be 2 points, A and B. You're going to call one of them like the first point and the other one the second. Okay, so promise once we start practicing, this won't be as intimidating. There's your formula. So another example, same thing. Find the length of RT, except this time I just have to plot the points. So R is at -2, -1, and T is at -8, 7. So what I want you guys to do, and I want to show you both ways, like I said, the formula and Pythagorean theorem. I kind of just did show you the Pythagorean theorem. So I want you guys to see, can you do Pythagorean theorem? Can you make a triangle out of this thing? Can you count the 2 green pieces and then do Pythagorean theorem to find the length? See if you can. Okay, more difficult formula out of the way. Now we're going to shift gears and talk about the midpoint formula. So it can be really helpful to find the middle of something. That's what a midpoint is. For example, if you're talking about like quiz scores in class, say that Billy or you got a 60% on his first quiz and a 90% on his second quiz. If you wanted to find the middle or the average quiz score, how would you do that? Well, you would take his scores, 60 and 90, and you'd add them together. This is very useful if you don't know how to find averages. You add the scores together, and then you divide by how many scores there were in total. So there's 2 quiz scores I'm looking at. So his average would be 75% on his quizzes. Now, we can do the same thing here on the coordinate plane. It's very exciting stuff. And we're doing it with segments. But essentially, to find the middle, we just have to find the middle of the 2 coordinates. And by coordinates, I just mean like the middle of the x's and the middle of the y's. So here's where the second formula comes in. Same thing. You do not have to memorize this. You just have to know how to use it. You're going to see the x1s and x2s again. It's giant parentheses because this ends up being, and that's a comma, this is written as an ordered pair when on the front, your length is going to be written as just one number. Okay, so keep that in mind. When you find the length, it's just a number. When you find the midpoint, it's going to be an ordered pair because it's a location on the x and y axis. So you have to write that as an ordered pair. The left one, up one, or whatever it is. So jump right into this one. I want to find the middle of this blue segment here. Sorry if yours isn't in color. So what do? Okay, I want to just go ahead and use the formula. I can eyeball it like, the middle looks right about there, but we don't want to guess. We want to be exact. So I need to figure out what ordered pair is this, what ordered pair is that. That's where I'm going to get my x1s and y1s. So this is the ordered pair, -3, -3. And this is the ordered pair, 2, 1, 2, 3, 4, 5, 5. Okay, so I'm going to rewrite them right here so you can see it a little bit better. To use my formula, the first thing I would do is I would label x and y. First number is x, second is y. This is the first ordered pair, this is the second. Doesn't matter which one's which. Now I just have to be real careful when I'm plugging in. So into my formula, the x value of my midpoint, it's going to be two numbers, I add the x's together, so that's -3 plus 2. Divide that by 2 because there's two numbers. So I'm just adding the x's, dividing it by 2. I'm averaging the x's. For the y's, I'm going to add the two y values, y1 plus y2, -3 plus 5. Divide that by 2. I'm averaging the two y values here. So I'm doing exactly what I did with Billy's quiz scores. Sounds weird. Except with points on the x and y axis. I don't need my calculator. -3 plus 2 is -1. I'm just going to leave that as -1/2. You can write as a decimal, it doesn't matter. I'm not picky about that. -3 plus 5 is 2, so that would just be 2 divided by 2, which is just 1. So that would be the midpoint. And if I plotted it like about left a half, up 1, that looks about right. Okay. Example 2 says QS has endpoints, this and this. So I want to find the midpoint, call it M, and then I want to find QM. This means find the length to the nearest tenth. So here's what I'm going to do. I'm going to show you how to set up midpoint. So I would start, take your ordered pairs, call them X1, Y1, X2, Y2. And I'm going to plug it into the midpoint formula. I don't even need the picture. I can just use the formula. Pictures always help, but not necessary. So I'm going to add the x's together. 3 plus 7, x1 plus x2 divided by 2. Add the y's together. 5 plus -9 divided by 2. Okay, I want you guys to finish that and tell me what the midpoint is. In class on next time I see you, so on Friday, I'm going to go through and show you how to find the length of a segment using the distance formula. I'm going to go through that real slow. So leave room, leave this blank. We will go through the formula for distance together. Okay, last example. So this one, they give me the midpoint of some segment Kn is 3, 4. Then they tell me one of the endpoints, we'll say it's K, has the coordinates of -3, -2. I want to find the coordinates of M. They're giving me the graph because they're encouraging me to draw this out and use a picture of it. So let's call the midpoint M. Let's plot that point. 3, 4. So there's the midpoint. And let's get the endpoint K on here. So -3, -2. So N has to be somewhere over here. I'll kind of like start drawing it. N is somewhere over here. If M is in the middle and K is the other endpoint, I need to figure out where it is. So you could do two things. I think slope, honestly. This is the easiest way for me. You can use the formula, the midpoint formula, totally, but here's all I do. I just count it. It should be consistent if M is right in the middle. So here's what I mean. I count from K to M. So I say, okay, to get to M, I go up 1, 2, 3, 4, 5, 6, and I go right, that was 6. 1, 2, 3, 4, 5, 6. Okay, I should be able to go up and right 6 again and land at N. This is going to work every time. So start at M and go up 1, 2, 3, 4, 5, 6, and right 1, 2, 3, 4, 5, 6. Ooh, I was pretty close to my drawing. This graph is tiny. Sorry about that. But that's where N would be. So I just have to say what ordered pair that is. So let me just count it on my miniature graph here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I should go up 10, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Whew. That was rough. So n would be at 9